Okay, you guys, so before we get going on proving that additional parts are congruent after triangles are congruent, I just want to point out something that will give you a hint that you must use CPCTC somewhere in your proof. So if you guys see our original proofs that we did, okay, the ones that we did before the CPCTC thing, if you see it says prove this triangle is congruent to that triangle. Prove this triangle is congruent to that triangle. Prove this triangle is congruent to that triangle. And prove this triangle is congruent to that triangle. Okay, so if you guys are proving that triangles are congruent, your last reason should say either SSS, SAS, AAS, or ASA. Okay, that should be your final reason, which if you guys think back to when we did this a little while ago, okay, if I show you here, like my last statement, my last reason has one of our shortcuts, AAS and ASA. This one, our last statement was proving triangles are congruent and our reason was SSS. Our last statement was proving triangles are congruent and our last reason was SAS. Okay, and with this one, our last statement was proving triangles are congruent and our reason was ASA. Okay, so that's kind of the pattern. If your last statement is to prove triangles are congruent, then your final reason should be one of our shortcuts. Now, the proofs that I'm going to give you, if you see, after we learn about CPCTC, if you guys notice, the prove does not have triangles are congruent. Okay, so if you have triangles in your problem, okay, and your proof does not say triangle da 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 is congruent to triangle la di da, that means CPCTC must appear in your final statement or reason. Okay, so to show additional sides and angles are congruent, your final reason will be CPCTC every single time. Okay, and in order to use CPCTC, somewhere in your proof, you have to show that your triangles are congruent. Okay, so somewhere in the proof, probably in most cases will be right before we use CPCTC, we need to show that the triangles are congruent using one of our nifty shortcuts, so SSS, SAS, ASA, and AAS. Okay, after we show triangles are congruent, that means all the remaining sides and angles that we did not use to show like triangles are congruent by side, 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 for example. So if we prove triangles are congruent by side, 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 that has to mean that the remaining three angles that we did not mark in our picture have to be congruent because your triangles are congruent. Okay, so what we must do, this is the game plan, we must show somehow that our triangles are congruent. So this will look just like the proofs we just did. Your second to last statement will be triangle la-di-da is congruent to triangle da-da-da. Then after that, the reason why these additional sides and angles are congruent is because of CPCTC, because our corresponding parts of congruent triangles are congruent. Okay, so that's kind of how these proofs are going to look. Your last reason will be CPCTC, and right before it, you will have proven triangles are congruent. Okay, which you're probably like, Miss Long, right now you're like speaking another language because I don't know what you are talking about. Well, that's okay. It will make more sense when I do a proof. So guess what? Why don't we do a proof, right? Doesn't that sound like a blast? I know, I agree. Okay, so let's get going on example 21. Okay, so I have been given that segment XZ is perpendicular like a cat. Board slapper. Alright, so XZ is perpendicular to WI. We're also given that ZXW, so I'm going to mark this in my picture if I quit dropping my pins. Jeez, so long. So I know that ZXW is congruent to ZXY. Okay, and I want to prove, I'm not proving triangles are congruent. I want to eventually show that WZ and ZY are congruent. Okay, so basically, you guys, I can already set up my proof because when you are trying to prove triangles are congruent and you're proving, or if you have triangles and you're not proving they're congruent, your reason, like 95% of the time, is going to be CPCTC. Okay, so I already know that my final statement, which I want to make sure my colors line up because I'm a nerd, so let's see here. 1, 2, 3, 4, 5, 6. Okay, so I'm going to say that WZ is congruent to ZY, and since this is not triangle whatever is congruent to the other triangle, I know that my reason has to be CPCTC. Has to be. So I already know. Okay, but in order to use CPCTC, my previous statement has to have triangle something is congruent to triangle something, which I'm not going to write those in yet because remember, it's very important the way that we label our triangles when they're congruent. And the reason is going to be one of those shortcuts. So my reason right here is either going to be SSS, SAS, ASA, or AAA. Or no. Miss Long's on the Demon Cascade, not Demon Cascade, not AAA, angle side. Sorry, guys. Well, that was a close call. Guys, so when the proof does not say triangles, whatever, is congruent to triangle, whatever, this is how your proof is going to look. We got to show triangles are congruent, and then after that, every other part and angle that we did not use to prove triangles are congruent have to be congruent because corresponding parts of congruent triangles are congruent. Okay, which again, if that still does not make sense, probably after I do the proof it'll make sense. So I'm going to shut my mouth so I can go through how this will work. Okay, let's get going, you guys. So like normal, we always write the given first. So I'm going to say that XZ is perpendicular to WY. And then I also know that angle ZXW is congruent to angle ZXY by our given. Okay, so remember you guys, when we're doing these proofs, if you spot something in the given or previous statement, any key phrases that might help you, that is something you need to look at when you're doing your proof. Which, do you guys see anything in the given that might help us move on to our next thing? Whoa, I see it to you guys. It is the fact that they're perpendicular. What does it mean to be perpendicular? Everyone take out that note sheet that I gave you a while back with all those definitions and theorems and postulates on it. What does it mean to be perpendicular? Well, if two segments or lines are perpendicular, that means they intersect and form technically 4 90-degree angles. Okay, so when XC hits segment WY, it's going to make 2 90-degree angles. Okay, so since that's what it means to be perpendicular, by my definition of perpendicular, I know that these two angles are 90 degrees. So I know that angle, let's see here, angle XZW and angle XZY, and I did not save enough space, so sorry guys, are right angles. And I know that by my definition of perpendicular. All right, now remember you guys, if you have right angles marked in your picture, that is not telling you they're congruent. All that's telling me is that these are right angles. But since we know that right angles are 90 degrees, it has to mean that they are congruent. So I also know that, let's see here, angle XZW is congruent to angle, just let me think for 1 second. Yeah, XZW is congruent to XZY. And again, if you look at that nifty packet, the reason why I can say that is because all right angles are congruent. Remember, it doesn't have a special name or anything. It's just simply all right angles are congruent. So all right angles are congruent. Okay, so I know now that these two are congruent. Okay, so I'm getting really close to showing that my triangles are congruent. Okay, so, which let me think for a second. This long. Sorry guys, I just realized that technically I could add, I'm gonna add in a line because technically there's something else that I could use to show my triangles are congruent. So I'm going to divide that. I know they're not even anymore, but it's going to be okay. I promise. Okay, so I'm really close to showing that two triangles are congruent. I'm so close. Okay, but currently I only have two things marked congruent. I only have an angle and an angle. I need three parts to use one of our shortcuts to show triangles are congruent. So do you guys spot any of those tricks up my sleeve that I can use to mark something else congruent in my picture? Oh man, I see it too, you guys. Whoa. Okay, I see that XZ is a shared side. XZ is in this triangle and this triangle. So I can say that X to the Z is congruent to X to the Z because it's a shared side. And when we say something is congruent to itself, that is by the reflexive property. Yay! Reflexive property. All right, now the reason why I did this extra line is because technically there is something else I can mark in my picture, which would allow me to show the triangles are congruent in two different ways, which is pretty cool. But, you know, as of right now, I do have enough information to show my triangles are congruent. Do you guys spot the way that these two triangles are congruent? Do you see it? Oh man, do you guys see there's an angle, then a side, then an angle? Okay, so these two triangles are currently marked with ASA, and then angle, side, angle. So also these two are congruent by angle, side, angle. So now I can say my two triangles are congruent by angle, side, angle. And now remember, it's very important the way we write our triangle congruency statement. So let's see, if I do it this way, if I do X, I'm going to do XCW. Why not? XCW. Okay, so I have an angle mark congruent, then I have a side mark congruent, and then I have a right angle. So normal angle, side, right angle. Okay, so I need to go the same way. So if I want to go normal angle, then side, then right angle, that's kind of going this way. So this triangle will be XZY. Nice. Okay, now technically I could be done with my proof because since I have shown that my two triangles are now congruent, that means every other side and angle that I currently don't have marked in my picture as congruent has to be congruent, because if two triangles are congruent, by definition that means that all angles and all sides are congruent. So now I am allowed to say that WZ and ZY are congruent because the two triangles are congruent, which means the remaining corresponding parts are congruent. Okay, so CPCTC always comes after proving triangles are congruent. I have shown triangles are congruent. I know I do not have WZ and ZY marked in my picture as congruent, but since my triangles have now been declared to be congruent, every remaining side and angle are congruent. So I could also say like angle W and Y have to be congruent. W and Y are both in my third spot, so they're congruent. I could also say that XW and XY are congruent. XW are in spots 1 and 3. XY are in spots 1 and 3. Guys, so I can now say that every other side and angle that I did not mark in my picture as congruent has to be congruent. And that reason is always CPCTC. Always. Corresponding parts of congruent triangles are congruent. Okay, so that's kind of the flow of how these proofs will go. We're going to prove triangles are congruent, which means every other part inside, every other angle inside that I did not originally mark congruent has to be congruent by CPCTC. Okay, now, getting back to this random spot that I've left blank. Okay, and I purposely didn't mark this in my picture because I wanted to show another way you can show triangles are congruent, which is pretty cool. Guys, so also, since I know that two angles in my picture are congruent, that has to mean that these two angles are congruent. Okay, I know that W and Y are congruent because if two angles are congruent, the third angles have to be congruent by the third angle theorem. Guys, so I'm going to say angle W is congruent to angle Y because of the third angle theorem. Third angle theorem. So in addition to ASA, I can also say using this statement that triangles are congruent by angle, angle, side. Angle, angle, side. I could also go the other way. I could say like angle, angle side, angle, angle side. Okay, so triangles are also congruent by angle, angle side because of this one. Okay, the reflexive property got me to the ASA. So, again, I just want to show you all the possibilities. So, by the third angle theorem, you could also show triangles are congruent by angle, angle side. And so, since we super proved that the two triangles are definitely congruent, my remaining sides and angles, so WZ and ZY, I could also say WX and XY, now have to be congruent because triangles are congruent. And that reason is CPCTC. Okay, you're probably like, Miss Long, you've repeated the same thing like 10 times. Please stop talking. Well, that's okay. I'll stop talking, but before I stop talking, we're super excited, so I'm going to put a happy face. Nice job, you guys. So, if you think you kind of get the message, you're kind of getting it, we're about to do example 22. Okay, so if you want to try this one on your own, you can. So again, game plan, show triangles are congruent. After that, any additional angle or side is congruent by CPCTC. So just keep that in mind. Okay, in a moment, we'll be starting example 22. Get excited.